Hello guys and welcome back. So now we're going to take a look at the result that we've created. Let's see what we've got. Hit play. Okay, I'm going to copy the preview color thing, paste that, and let's lower this maybe 4, it's 5, yep. And I'd like to move this over here and maybe add even a darker color. I'm gonna change this transition so it's smoother by using the Catmull Rom method. In some cases it's linear. Set this to brighter white, okay. And let's change this to black and make sure it's set to points. Yeah, pixels. And let's play it. 120 frames. And the point count with this was 1 million, I think, towards the end. And I would definitely increase that to between 4 and 10 millions, depends on how much you can push your sim. But to get all the fine details, we need a lot more point than this. And so far, I really like the motion. I think it's even better than the first one I did. And yeah, it's working. You can see a lot of cool fluid motions. You see the particles that escapes end up being here, and the ones at the top as well, they're being nicely attracted. And I think it's working pretty well. Maybe we can lower the force applied to the exterior particles, but I like this jumping at the outer layer. I think it's very, very cool. Okay, so now we're going to take a look at something that I haven't done in my example, but I think it will help me teach you guys some cool stuff about the point VOP. So what I'm going to do is I'm going to take a still frame of this. Let's say how much? 36. Let's go maybe here. Okay, and I'm going to do a time shift. I'm going to delete all the attributes. The time shift, I'm going to set it to 10 so it doesn't change. I'm going to delete all the attributes except the color and the point. Everything else we delete. Cool. I'm going to create a new pop network, and I'm going to emit these guys in one frame. So $f equal 1, and give them, they live forever. And all points, hit play, we should emit the points. Let's make sure the color is there. Yeah. Let's add a gravity node to make sure that it's working. Yeah, it's working. The reason we're not seeing them is because this guy is overriding this guide display. I'm going to turn that off so I don't see the source itself, we just see the result. Let's turn this off. Okay, so now we emitted the points that we had before. Still, we didn't do anything. And because there is no motion, there is nothing here, nothing is happening. But if I create a pop force, set this to 3, this to 4, hit play, something happens. Okay, so what I'm going to do is I'm going to create a pop VOP, and this is similar to the point VOP, except that it's at the DOP level. Okay, and what I'm going to do is, remember the first week we took the P position and we subtracted a specific location from it and created a vector, and each one of these guys, they have a point right now. If we go here, we have the point position. I can plug that into the normal. Can plug that into the normal and visualize the position vector. So it's like that, and we can flip it. And it's aiming inside. So if we take these points and copy their position into the normals, we can create a velocity vector on the fly here. So let's do that. I'm going to take the position and simply plug it into the velocity. hit play, and it's expanding. Okay, that's because it's pushing outwards. So let's negate this guy. Negate means flip a vector. Okay, so it's going downward. Well, if we take this this velocity vector thing, maybe let's pick a different frame here. So if we take the position, which is going inside, and compute the cross product between that and an up vector, which is 0, 1, 0, we should get an interesting vector. Okay, this is the point position, and now we're computing the cross product of that. Let's use the cross product instead as a velocity. So I'm going to take the point position, I'm going to compute the cross product with an up vector and plug that into n. If we hit play, interesting, the points are rotating, and that's what the cross product vector is. Before it was pointing here, and now it's pointing upside in this direction. And if we play it through, it's going to rotate. So, but I don't want it to rotate along this axis. So I'm going to change this to be positive in z. And if we hit play now, it's going to rotate in that orientation. Very, very interesting. Okay, let's mix this in with the rotation. So I'm going to use a mix node. Let's hit play. And now it's rotating and getting attracted to the center. Let's add a multiplier. And let's multiply this by 2. Let's hit play. And now it's rotating more. And it's getting attracted to the center. It's going to keep doing that forever until it reaches 0. Okay, so what I want to do is I want to create an interesting force to do the attraction. But right now it's very, very linear. So what I'm going to do is I'm going to normalize both of these guys. I'm actually going to normalize this as well, just to be. And we have, after normalizing it, the force applied to the closest one is stronger than the one outside because it's closer, so it's gonna move faster, and this is going to help us a lot to convey the effect that we want. And what I want to do is I want to create a swirly and attracting force to suck these particles in an interesting way. So this is so far cool. I like this. And what I want to do is I want to, instead of using the position here, I want to compute the new vector myself. So I'm going to take the position and subtract 0 from it. So that should give us the exact same result because that's what the position is. If we plug this in here, should see the exact same result. But the cool thing now is I can do this. I can add a noise to the position, and instead of using their current original position, I can use something different. I can use an offsetted version of that. So let's add this noise, set it to 3D noise. Let's increase the frequency, and let's hit play. And now we should see, yeah, see it? It's different now. It's not the same anymore. And the more force we have, the more noise we have, the more disturbed the result it's going to be. See, now it's much, the noise is very, very small. So let's set it to 8, 8, and 8. Cool. See, it's broken up now. I'm getting some cool details there. I'm going to copy this. I'm going to set this to 2. I'm going to copy it. And add another one, set it to 1. Set these guys to 3. So we get 2 layers of noise. Okay. Very cool. Now one more thing I'd like to do is I want to be able to control which point is getting affected by all of this. Okay, and actually let me try something super quick. In theory, we should be adding to the velocity itself. We shouldn't be overriding the velocity completely, and it's gives us completely different effect. So let's, in this case, I'm going to override the velocity completely, but in other examples we may have to just use the force, which gets applied more physically more correct. But in this case I want to dedicate what's going to happen to the particles, and later we can add a mix in and mix the previous velocity with this current one, or slowly introduce it. Okay, so what do I want to do? I want to take the position and compute a length of how far it is from the center. So let's compute the length of this guy. Let's plug it into the color. So it's white. Let's put down a fit range and try to get it so that it's black here and white here, or the inverse. It's white here and black here. So let's say 4, 5, 6, say 4, okay, 3. Let's inverse this. So now it's white at the center. Cool. So it's white here and black at the center. And I'm going to use this as a multiplier to all this force, and I'll explain why in a second. Let's turn this off, turn this in, hit play. Now the center part is going to get affected more than the outer layer, and once these guys get closer, they're going to get affected more and more and more and more, and this is very, very cool and powerful. Now I'm going to tweak this ramp a bit. I want to grab all the points as well, and I want to also, now we're multiplying everything, I want to multiply only the section which is happening here with the velocity, with the ramp. So this guy is getting its own multiplier. Cool. So the closer it gets, the faster it's gonna get sucked in into the center. And let's set this to 2. Let's copy this and set this to 6. I want it to rotate less and get sucked in faster. I'm surprised that this is not going towards the center. Set this to 4 and this to 4 as well. It's not going to the center. I'm not so sure why at this point, but I think you guys got the idea. And now we can take the existing particles and maybe even keep their velocity at the current speed at, let me think. So yeah, we can keep the current particles getting emitted every frame and then add a secondary effect to control them. And again, the main thing I wanted to teach here is how to use the point VOP to create custom attraction forces. Let me turn this off. Reduce this to 1. Make sure everything is getting captured. I set this to 6. Cool. I don't know why it's moving to that angle at the moment, but I think you guys got the idea. Thank you for watching, and see you in a bit.